Okay, so we're going to look at example 4 on page 87 of the workbook. This is another example of using L'Hopital's rule to calculate a limit. Okay, and what it would like us to do in this question is to revisit parts of example 1 on page 86. Okay, some limits that we already looked at. And the question they're asking us is, could we use L'Hopital's rule to evaluate either of these limits? Well, let's start with the limit in part A. Okay, so I'm just recopying the limit from back on page 86. It looked like this. The limit as x goes to infinity of x squared plus 1 over x squared minus 1. Okay, could we use L'Hopital's rule on that? Okay, well, it comes down to the question of, is this one of our 5 indeterminate forms? So as x goes to infinity, how is our function behaving? So on the numerator, x squared plus 1, notice that that gets big as x approaches infinity. So that numerator is headed off to infinity. And the denominator, same deal. If x gets really, really big, x squared minus 1 is going to go off to infinity. Okay, if we just take a quick look back at the top of the page, infinity over infinity, that's one of our 5 forms, okay, which means that we can use L'Hopital's rule to do this limit. Okay, so just to save some space here, I'm going to get rid of that. Okay, and we'll proceed to use L'Hopital's rule here, which again involves taking the derivative of the top and the bottom. So the derivative of x squared plus 1 is just 2x, and the derivative of x squared minus 1 is 2x. Notice that after we take those derivatives, we get cancellation here. And we're just taking the limit as x goes to infinity of 1. Okay, and there are no x's left, so we're just going to get 1 out of that limit. And notice that that confirms the answer that we got back on page 86. Okay, so we were able to use L'Hopital's rule for part A. What about part E? Okay, well, that limit, and again, this is referring back to the previous page. The limit in part E was the limit as x approaches 1 from the right of the same function. And same question, can we use L'Hopital's rule to evaluate this limit? Okay, well, let's examine the numerator and the denominator and see how they're behaving. So as x approaches 1, the numerator is going to approach 1 squared plus 2, which is 2. Okay, and down in the bottom, what's happening there? Okay, if we plug 1 into the denominator, we're going to get 0. But which side of 0 are we going to be approaching from? Since x is approaching 1 from the right, we're talking about x values that are a little bit bigger than 1, which means that our denominator is going to be a little bit positive, a little bit bigger than 0. I'm going to write that down by writing 0 plus. Okay, so in words, we would kind of look at this and say 2 divided by very small positive numbers. And the question is that an indeterminate form? Okay, well, you can look back at the top of the page and see that 2 over 0 is not an indeterminate form, which means that we can't use L'Hopital's rule here. We need to do this a different way. Okay, well, let's just maybe write that down so that you've got that in your notes. This is not indeterminate. Okay, so we can't use L'Hopital's rule. Okay, and so hopefully we can figure out what this limit is some other way, and I think we can do it just by sort of thinking logically about what's happening. So ask yourself, as you look back at this fraction here, what would happen if you took the number 2 and you divided it by smaller and smaller and smaller numbers? How would the whole fraction behave? Okay, well, I claim that because the denominator is getting smaller, that must mean the entire fraction is getting bigger and approaching infinity. Okay, if you're skeptical of that or wondering about where that came from, we can do a little experiment here. Okay, how do we really know that this fraction up here gets bigger in this case? Well, you can take out your calculator and maybe do this with me. If we take 2 and just start dividing it by smaller and smaller numbers, maybe 0.1, 0.01, 0.001, and so on, that's really what's kind of going on in this fraction up here. If you do these calculations, here's what you're going to find. 2 over 0.1 is 20, then 200, then 2,000, then 20,000, and you can kind of see that these numbers are indeed approaching infinity. And that's what we're saying. Okay, that's where this answer